So we're now into our second speaker, Chris Brown of ARM. I'm hoping Chris has got some good questions for our panel at the end, as he usually has each year. Chris Brown from ARM is the Director of Engineering. His talk is on applying the theory of marginal gains to boost verification effectiveness. Dr. Chris Brown joined ARM in 2014 and is part of the Cambridge CPU verification leadership team. He has 22 years experience leading, managing verification teams in both digital and mixed signal applications. Thank you.
Thank you. So, as Mike said, I'm from the CPU group in Cambridge. We've been doing some work over the last year or so to try and boost our effectiveness. These three guys on the bottom here did most of the work, so I need to make sure they get their share of the credit. I'm just talking about somebody else's stuff, but they did all the work. So, I'm going to start just by talking a bit about what the theory of marginal gains is. Those of you who have followed the British sporting world, particularly British cycling, will have heard of that, and you'll know that your Jiffy bag is at the desk on the way out. So I'll talk a little bit about what that means, what marginal gains is all about, and then I'm going to talk about some of the marginal gains that we've been doing to try and improve the productivity of our engineers, the particular steps that we've taken. Just start by talking about what the theory of marginal gains is. And the idea here is to stop looking for silver bullets, for magic bullets. Not necessarily stop, but stop relying on them. If you're sat next to an EDA vendor now, they're just elbowing the ribs, going, "Don't worry, I've got a magic bullet." We've had some good stuff. We've had some in the last couple of decades in verification. We've had constrained random coming in, formal requirements tracing coverage, all these things. They are great things, and I'm not knocking those. I was saying that it's not just the big things. If we have lots of little things, lots of small improvements, the 1% gains, they can actually all add up to be something pretty massive for us. So if you think about the things that your engineers spend every hour of every day doing, if you can find a small gain in that, it multiplies up massively. If you can think of something that you do a lot of, you spend a lot of time doing, or your computer spend a lot of time doing, if you can make a few small gains in that area, you can make a massive productivity gain. You can also get massive effectiveness gains as well. So that's the general idea. Not knocking the big things, but let's not forget the little things. So one of the things I like to do to give me inspirations, give me ideas, is to benchmark what I do against other people. That's one of the reasons I come here every year, to find out what other people are doing and just compare, am I behind, am I ahead, am I level? And it's very useful, gives you ideas, gives you things to do something different. Something else that we can use in our hardware world is actually what software guys do. Software guys are always ahead of us in terms of complexity of their systems, certainly the top end of software anyway. So they're dealing with much larger complex systems. They are dealing with much larger teams. And to be honest, in a lot of cases, their development processes are ahead of what we do in hardware because they've had to tackle these problems earlier than we have. So one of the things we did last year is we had a look at software development processes, looking for inspirations for things that we can do to improve our verification. And if you think about a modern test bench, it is a reasonably complex object-oriented software system. All right, it might be tens of thousands or hundreds of thousands of lines rather than millions of lines of code, but it's still reasonably complex object-oriented system that you're dealing with there. So why not use the techniques that the software guys have developed for their massive object-oriented systems for our medium-sized ones? So we went through looking for marginal gains, that ideas we could steal from the software guys. Now, you can see that the ones we particularly decided to look at there, unit test, reviews, done means done in education. And I'll talk a little bit more about what we mean by those in the next few slides. What I hope to do today is not necessarily say, hey, you guys, you all need to go and do that, but just encourage you to go back to your teams and look for your marginal gains. You might find that these are useful. You may find other ones that are useful for your team. It depends where you are and what you're doing. But go look for these little things. So I'll start by talking about unit testing. So it's the first of our little marginal gains. So if you think about the way we develop test benches, and we have done for the last 20 odd years, guilty, I've done it all the time. We write large amounts of code. We write thousands of lines of code, in our test bench, and then we take that and we run it against a load of new RTL and we try and bring it up. What if we'd tested our test bench on its own as we were going on? What if we'd been able to test parts of it so that when we brought it to the RTL, we knew our test bench was actually pretty good? Maybe that would be a good thing to do. Partly because of this, we spent a shed load of time late in our projects debugging test benches, finding corner cases in the test bench, trying to fix the test bench. And that doesn't actually sound like a great use of our time. What if, because we've taken development and testing of our test bench seriously, at the later stage of the project, our test bench is actually robust? What if most of the bugs are in the RTL and not in the test bench? That means we can make the designers debug all the regression failures, because it's probably their fault, probably not the verification engineer's fault. When we're in this world, if we make a change to our test bench to try and fix a corner case in our test bench, we've got to run a massive regression, take a whole load of compute cycles, just to show to ourselves that we fixed the corner case problem in our test bench. What if we could run a load of small tests just on our test bench really quickly in a few minutes that would show us that we fixed our corner case bug in our test bench and we haven't actually broken anything else in the test bench? So how could we do this? Well, I've already told you in the header slide, unit testing. Unit testing is a way of doing this. We want to be clear what I mean by unit testing. Unit testing in this case, I'm talking completely about the test bench. I'm not talking about units of the design. I'm not talking about the RTL or anything like that. I'm talking about units of the test bench. So we're talking about functions. We're talking about base classes, that kind of thing. This isn't unit verification in the IP sense. This is unit verification, testing small parts of the test bench, thinking of it as a software thing. So by doing this, I have confidence in all these little parts of my test bench, all these functions. I know that it's going to do what I thought it was going to do before I start bringing all the test bench together. This is a well-proven practice in the software world. I remember a wise old man about 20 years ago when I was first starting this game saying, you need to do unit testing in the test bench. And me, being young and arrogant at the time, went, yeah, old man. Well, now I think he was actually a very smart guy, and I should have listened to him, but sadly I didn't. But I'm listening now, Graham. There are studies around that show all sorts of numbers. We all know about our mythical verification numbers, but there is a study back from 2014 that shows that a significant amount of test bench guys' days is spent debugging their code. So if we can use unit testing to get rid of all these bugs early, then we can make a dramatic difference to their day. So they are writing new tests, they are adding new coverage, they are finding new bugs in the RTL, not having to spend ages debugging their own test bench. Another really nice thing it gives us is it enables us to decouple the schedules. So you think about my first where we've been column in that slide. You were bringing up the test bench against the RTL. So you couldn't really bring the test bench up until you had RTL. So the test bench is always behind the RTL. So the verification person is always the long pole. If you use unit test, they can actually be bringing the test bench up, they can be designing the test bench without RTL. So you can get to that mythical point where the RTL arrives and the test bench arrives on the same day, and they can be brought up together. You're not behind the RTL. It also, if you've got a large test bench where there's lots of people working on it, and at ARM we have some pretty large test bench teams, you can decouple the schedule within that as well. So Sally isn't waiting for Jimmy to finish his because she's got a unit test around her part of the code, so she can bring her code up before Jimmy has finished. So you're decoupling the schedules within a large test bench team as well. Another really nice thing that it provides, it's almost like an extra bit of documentation to go with your test benches. We all write really good documentation for our test benches, I'm sure. But this can add as an extra piece of documentation. So if I'm given a piece of code from a test bench that, say the person who wrote it has left, and I'm trying to figure out how on earth do I use this piece of code. I've got to go and make some modifications to it. I've got a nice set of tests that document how the person really intended it to work, how it worked. And then I can make some changes knowing that I shouldn't break the old behaviors because there are tests to go and catch that. So that really helps. There is a logical extension of this to something called test-driven development, which you'll also hear people talk about in the software world, where you actually write the test first. So you write the specification for the code, you write the test, and then you write the code. We haven't quite gone that far, though we do have 1 or 2 supporters of that in our team, but we're just going down the unit test at the moment, and we're looking for the pragmatic value out of that. Final thing I'll just say on unit tests. So there are unit testing frameworks available to you. We, in the CPU group, we have test benches written in System Verilog UVM, we have Python, we have C++. For the UVM ones, we're using this SV unit, which is a open source unit testing framework that works well with all the different simulators, works with UVM, it supports all modules, interfaces, classes, all that kind of stuff. It's very simple to use. We took some of our engineers, we sat them down, we said, this is what unit testing is, here's the framework. A few minutes later, they're writing unit tests and they're up and productive. So this is a really nice, easy way to get going on this. We have designers now, test bench writers now, who will, if they see a regression failure that they think is a test bench problem, they will actually go to unit testing first and try and replicate it in unit test rather than debug with all the design and the entire test bench. So which is caught on quite well within our group. Okay, so our next marginal gain. So this one's a little controversial. This one can cause you a few problems, but it's quite valuable. So you've all heard code is written once, it's read many times. I don't believe that. Code is written once, it's debugged many times. And we're using our unit test to reduce the amount of debug, but we still spend a lot of our time debugging. Again, if we can get rid of those bugs earlier, so we don't actually have to debug them, that's a massive win for us. And studies have shown that code review is one of the most cost-effective way of eliminating bugs. You eliminate them at source. So we've introduced compulsory code reviews on all our test bench code. This allows our experienced engineers to kind of oversee larger areas. It allows us to share knowledge around the group. So there isn't just one person who knows how this bit works anymore, because other people have been reviewing it, they understand it. If somebody's off sick or somebody's left or somebody's been hit by the boss, we're still protected. We have somebody else who understands it. We have already seen the quality of our code rise as a result of this, because people know, well, my code's going to get reviewed, so I'm going to make sure it's really good beforehand. And people who have systematic bad code learn that it's bad code and they fix it. ARM has had a code reviewing strategy for a while, but it's tended to review lots of code at the end when it's hard to really do something about. So now we're doing short codes reviews as we're going along. This is just a snippet from a code review checklist, just something to get started with. You can get people a bit power crazy with code review and they try to sort of force their bigoted opinions on everybody else. So we've got sort of guidelines as to what you're actually reviewing. If you Google code review checklists, you'll find ones out there to get you started with. And there are tools you can use. All our test benches are linted now, and there are Gerrit and Bitbucket and things like that to help automate the process. So our third marginal gain, done means done. And I've actually got, people use this phrase, I'm quite proud of it. I was talking with the VP of engineering the other day, and he said, what's this done means done thing about? So it's really taken off, this one. It's all about starting with the end in mind. If you are trying to keep to a schedule, when somebody says this task is done, it has to stay done. And if it has to be reopened later, all hell breaks loose. Particularly if it was a stimulus task in a test bench. If the stimulus wasn't good, then you open that task. You also probably end up opening the checker task because there was bugs in the checker you didn't find. You end up opening the RTL task because there was RTL bugs, then the implementation. So trying to get people, when they say it's done, it stays done. Stimulus to me is actually the most important one there, but we do have done measurements for all things. We don't like rules at ARM, so I've called these inspirations. There's a much longer list than that, but they're inspirations. So I want people to think about what they do. I don't want people to blindly do. So these are things you might think about. So some simple metrics. So for us, it might be how many floating point instructions, how many integers instructions you've done. If it's all integer, then you've got bad stimulus. It's that kind of thing. People don't look at waveforms enough these days. They're all in their class world and, well, look at the waveforms. If everything's red, nothing's happened. If your main state machine has stayed in idle time, nothing's happened. So just getting people to go look at things like that. This one at the bottom, if you haven't found any bugs, you haven't worked hard enough, your stimulus isn't good enough. There are bugs out there. Go try harder. So that's just some kind of inspirations, and we have others as well. The last marginal gain is education. So most of our hardware verification people, the majority, not all of them, come from an electronics background. So people like me, we went to university, we learned Ohm's law and Kirchhoff's law, and if we were paying attention, Maxwell's equations. We didn't learn object-oriented. We didn't learn how to program. We were just, oh, here's a bit of Pascal, go write something. So we looked at some of our object-oriented test benches, and they weren't very good. It was a class for absolutely everything, whether it made sense or not. We've got a couple of really good software guys in our verification team. So they put together this object-oriented programming workshop, and everybody who works on a test bench for our next round of projects have been through this workshop. It's about 8 people at a time. There are 4 sessions in the workshop. You spend 15 minutes listening to a lecture on one of these items, 45 minutes doing a pair programming exercise to test those concepts, half an hour discussing and having a sort of a model answer. This has given us a consistent terminology that we can use, so everybody talks the same language now. We can all talk refactoring in front of management and not tell them that we're rewriting the code, that kind of stuff. And this has worked really well. Now everybody, we've raised the quality of our engineering staff as a result. Mike's standing up, so I better finish. Quick summary. Every little bit does help, and I think we actually had that on the last slide of the last one. Every little bit helps. All these marginal gains, they all build up. Invest in improving the productivity of your engineers. Copy wherever you can from the software guys, steal all their great ideas, and invest in training your staff, because most of them probably are really working in an area that they weren't originally educated in. Okay, I'm done.
Thank you, Chris. Thank you. I think the first bullet may be ASDA, right? But anyway, so.
Seems like it's got inspired from Tesco then. Every little helps.
Tesco's,
Yes.
Tesco's.
Hey, do you rely on specifications to develop your unit tests? How do you think of what the unit tests need to look like, and what's the overhead of having good specifications?
So we write lots of specifications at ARM, and all our test benches will have a lot of specification. We spend a lot of time figuring out the right things to do before we start, and we will write a long specification. It probably doesn't go down to enough level of detail to actually specification for a function, for example. So the unit tests will be developed by the engineer that's going to write that function. They'll probably be reviewed as part of done means done with the unit leads. It's probably not detailed enough specification.
Yeah, so I guess my question was, how do you close this loop between specification, what it needed to be, what was missing, versus unit tests that were run later on? And yes, you may have closed verification holes. Can you find any validation holes? Things like that. Maybe that's not something that you have looked at.
It's not really what we've been trying to tackle.
Fair enough.
We've got 2 more questions.
When you say you do unit testing but not yet testing, in the sense that they are often used to, or most of the time used together, because when you write your test first, then at least you have seen it fail, because if there's not yet an implementation, it has to fail, so you get an additional level of quality, which is not guaranteed if you do it in the other order.
So, in my experience, engineers are quite cynical and skeptical. So if I go and push the idea of test-driven development, I'm pushing quite a large concept and quite a different, a big change to them. If I say, why don't you write some tests that shows that your function is actually working, that's a simple concept that I can get them to do. Will this evolve into a more test-driven development type technique in the longer term? I hope so, but I'm using language that I'm careful with to take my engineering staff on a journey with me. Does that make sense?
Small steps.
Small steps.
Every little helps.
Yeah.
Last question.
Anthony Wood from Imagination. I wanted to ask you about code reviews and why you came up with the way that you review code, and specifically whether you considered reviewing code for every submission, and if you did, why you rejected that?
So our code reviews happen when we check in, when we merge into the master branch. So that's when they're happening. Again, if I say, hey, everybody, let's do code reviews, I have to be very careful that I don't appear that I'm going to actually slow the process down and everybody's just going to spend all their life reviewing code as well. So I have to be very pragmatic in what I do. We've come up with what we believe is a pragmatic solution, and we will probably evolve it more as we're going along. But there's a lot of pragmatism in what we're doing and perhaps less idealism. And that's how we've driven deciding what we're going to do. Does that answer your question?
Is it successful? Are they on board?
People are doing it, and they are not complaining loudly enough to me or via another recruiter to get to me. To be fair, the Sophia CPU team did this on their last round of projects and are doing it on the next round of projects, and the people who complained at the start are no longer complaining. So this is something that if you can get people going and do it for long enough, they actually do start to genuinely see the value in it.
Chris, nice. Yeah, we are in GPU, we do code reviews on every commit. We do that. But as you said,
from a practical point of view, when you start, people don't like the idea. Especially when you're starting something from scratch, because there's a lot of code, and if you're reviewing every little bit.
Thank you. Yeah, I told you it was a good idea to have a plant in the audience. Have you ever thought about going to sprints? Full agile, a bit more agile, going to sprints?
So have I thought about it? Yes. It's not something that fits well with ARM's current development process.
Okay.